So we are recording the session now. So today's lecture is going to be about something which is extremely popular nowadays. How many of you have not used any large language model till today? That's not true. Have you used ChatGPT? That's a large language model, right? So there's no one here, I'm sure, in academics nowadays who has not used a large language model. Well, inferring or inferencing from a large language model, as we technically say it. So as I promised in the beginning of the course that we'll have, we're supposed to have one session on large language models. So this is that session. So hopefully you will be able to appreciate the use of parallelization and high performance computing that happens under the hood in these applications. And I'm sure many of you will actually use these applications given that you have an understanding of parallelization and computing now in the future as well. Okay. So that's what today's session is going to be about. So today's session will have, three parts to it. One is going to be a discussion on the applications of large language models, or in general we'll call it Gen AI, generative AI, artificial intelligence models. And we'll talk a bit about the theory of these, and then we'll also do some actual hands-on on inferencing, as well as doing some sort of a training of these models. Right. So this buzzword Gen AI is something that I'm sure most of you have heard or read in the last few months. So this stands for generative AI. Okay. When you generate information using artificial intelligence, technically speaking, using some sort of a machine learning model in most cases. So in the last lecture we talked about deep learning. Okay, so deep learning, the idea now, I'm sure you have some sort of an understanding of the idea of deep learning. So in deep learning you have an input, and using some sort of regression or lots of regressions, you come up with an output y, a y hat, okay, or f. So f is a function of the vector of inputs x, and that functionality can be quite complex in the sense that you can have lots of layers of neurons, and each layer can have lots of neurons which will make the structure very complex. So but what we talked about in the last lecture was something called a dense arrangement of networks, where each neuron in a layer is connected to all the input values x or activations depending on which layer we are talking about. So that's a very dense configuration. So there are different architectures possible. You can have different networks connected to each other in a certain way. So these architectures or connections have resulted in very interesting deep learning models. So one of these has been the recent transformers architecture, okay, on which now ChatGPT, Gemini and all these recent amazing large language models have been based on. In fact, not just large language models. Large language models are models which take in which do natural language processing. So you give in some information in the form of language, words, and it returns an answer to you, and using that answer you can do something interesting. So that is called a large language model. It's called large because it's a large network. It has lots of neurons in it. But there's another one that you may have seen. It's text to image. You write a text prompt, it results in an image as an output. Okay, so these are called diffusion models. So they have they again use networks like this, but the fundamentals are slightly different. They have some different connections, but they also fall under the overall characterization of these generative AI models, okay, which ultimately are a part of your deep learning models. All of these are deep learning models. So today's discussion is primarily going to be about large language models, where you give some text as an input and you get text as an output from that model. And why are we discussing it, and why are these models very popular nowadays, is because we have a lot of data. I mean, in the past we have been collecting data, but because of the recent technologies of storing lots of data and sharing lots of data, so we have ended up having a lot of information in the form of data, and also we have a lot of compute power in addition to the recent algorithmic achievements that we have in technology. So we have amazing algorithms, we have amazing hardware in the form of GPUs and CPUs and all these hybrid architectures of hardware, and we also have lots of data. So this is the golden period that you're living in. That's the reason you see this sudden boom of artificial intelligence happening nowadays. Okay, so at least we should have one discussion on that so that we understand what happens. Well, I won't say in a detail technically, but we have some sort of technical understanding of these things beyond simply using some sort of a website and like ChatGPT and writing a prompt and getting output from it. Okay. We'll talk about something called a generative AI project life cycle. So how does a life cycle of a project look like? And we'll focus our discussion on certain topics particularly which are interesting in the form of computing today. So what can you do in these generative AI models? Well, you can train these models from scratch. Okay, that is what OpenAI has done to get GPT or ChatGPT for us, or Google has done to get Gemini Advanced or Gemini Pro for us. So you train these models from scratch. So that's called pre-training in the LLM lingo. So that's called pre-training, but that's basically training the data from scratch on lots and lots of data. Okay, so that's something that you can do, develop a model from scratch, which we can, or what you can do is you can simply use one. That's what we actually do when we write a prompt on ChatGPT and we get an answer out of it. So that's we are using a already developed model. Okay, there's one more thing that you can do. You can pick an amazing model and make it even more amazing with something called fine tuning, and this is where the key technological developments lie nowadays. I mean, see, there are some companies which have lots and lots of compute power, like Meta, like Google, like OpenAI. So they will definitely pre-train models and give you these large models like Llama and so on. But as others will not be developing these huge models from scratch, what they'll do is they will fine tune them. So we'll talk about something called fine tuning as well today. So in this process of fine tuning, you basically take a model which is very general in nature, like ChatGPT, and you train it for a specific task to make it smart in that application, like for example high performance scientific computing. So you give it, I mean, it will have some understanding. I'm sure everybody has put in questions of the assignment in ChatGPT and see what sort of codes you get out of it, right? But it does have some shortcomings, or it's not as I mean similar to as how I write codes in the class or the codes that we have written. So if we fine tune it in the way we write codes in this class, then it can actually start giving us results which look very similar to how a student in the class would be writing a code. Okay, so this is called fine tuning. So I'll actually demonstrate training. This is also training. So we'll sort of train or fine tune an existing model in the class on a consumer hardware, which is my laptop, and I'll show you that we can do it in a few minutes. Of course, I mean that will be very trivial, but I can demonstrate that that is possible on a single simple laptop based GPU card, and if you have more resources, you can do a better job at fine tuning. Okay, we'll also discuss. So there are some models which are very general, which are very large in terms of the number of parameters they have. I'll tell you what it means. And there's some models which are very specific, which are trained for a very specific task. They are smaller in nature in terms of the number of parameters they have. And we'll also talk about prompt engineering briefly, very briefly. I mean, that's also getting very popular. What sort of prompt should you write to ChatGPT so that you get the best sort of an answer out of it? Okay. So this is going to be a discussion of today's lecture. Well, what are the applications? You name it. So chatbots to summarize information. If I give you a document, a legal document which is 50 pages long, It's very difficult first to read all those 50 pages. Second is to understand those 50 pages if you're not from the background. So if you feed that to a large language model which has been trained to summarize legal documents in lay language, then you can use these for summarizations. I mean, this is one example which actually I find quite interesting for understanding legal documents, which you find sometimes on the internet. The other is to write essays. So that's the other way around. So you give it some information and then it expands on it using its understanding of the subject and gives you a very nicely written essay, which I am sure your supervisor or your teacher can easily figure out with the kind of words they exist. But the idea is that it can expand on the information as well, on the topic as well. The other is translation. So it translates from one language to the other, sequence to sequence. Text to image using diffusion models, as we will briefly demonstrate to you today in the class. Information retrieval. So that's very interesting. It can retrieve information from certain sources as well. So in addition to just generating information, it can also retrieve. So it has to figure out. So if I ask the model that what is the temperature on this particular date or today, well, if you are just using an offline model, that cannot figure it out because it does not know. It only knows the information about the data that it was fed, but that definitely was some old data. But it can figure out that this is an information that I can find out from Google. So why not I connect through an API to Google, and then so all these things are possible nowadays. So it's not just using large language models, but things beyond that. Okay. So we'll not go into those things today, RAGs and all these things, but it is possible to connect to external APIs to these things. Coding support, well, I don't need to demonstrate that. If you write in the assignment 2 question, it gives you a code out. Okay. And see, in the future, I mean, if you're writing codes from scratch, then you are not doing things most effectively or most efficiently. Okay. So your time is also important. So if these language models which have been trained on lots of good quality codes are helping you with that, there's no problem. I mean, for the exam sake, don't do that. But if you think about the usage in general, what you can actually do much more amazing things, because if it gives you some sort of an outline of a code and you just have to find a few bugs and sort it out, and then you can do more amazing things with it. So within the limited amount of time you have, you can actually come up with very interesting output out of it, rather than writing things from scratch. Okay. So it's like you have a big team of 20 amazing programmers, and you have to understand programming. So this course was important, because if you start from a language model to generate code for you, then you'll never be able to understand what it is giving out. Okay. So you have to have a good understanding, some basic understanding, and then you can use these models to help you with that. It can also do some sort of reasoning nowadays and problem solving. That's also important. I mean, large language models are not very good at actually reasoning things properly, but they can give you steps. So if you give a problem, a very complex scientific problem, it can tell you that why don't you use these steps, then you do this, then you do this. So it actually helps you solve the problem, and then you can figure out if there are models which are experts in doing these steps, or if you can do it yourself, or delegate that to someone else. Connecting, as I said, you can connect these two APIs. For example, doing calculations. These LLMs have not been very good at doing mathematical calculations, but it can reason. So if you ask it to multiply do something more like integral, it can figure out that to do the integral I have to break it into some parts, and then I have to multiply the width of the interval with the function value, and then what it does is it sends or connects to an API through a calculator API, which calculates and gives the product back to this. So now it knows that, okay, now I have these values, I have to add them. Then again it sends an API call to a calculator and gets the summation. So this is the kind of developments that are happening, and so the whole life cycle allows you to manage that. Well, I don't need to discuss this. There is going to be a lot of boom of exponential increase in the use of LLMs in the market. So, LLMs typically you will see that, well, language models not just have different sizes depending on the number of parameters, and the definition has changed with time. What was large a few years ago is considered maybe small nowadays. So, from nowadays definition, anything which has parameters north of 180 billion is considered large. Again, there is no standard definition as such, but that's the overall consensus in the society and the community, that anything which is 180 billion above is considered large. So, GPT-4, it's they say that it's got GPT-4 in the future will have GPT models in the future will have trillions of parameters. So, parameters, if you remember the discussion on deep learning, is the number of weights that you have to train. That's what parameters mean, because I told you that these models are also deep learning models. So, in the end, it all boils down to finding those weights in the regression equations for those neurons. So, if you add, if you combine all the weights that you have to train or use for inferencing, that gives you the number of parameters. Okay, so that's what these parameters word means. So, that decides on how big the model is. Okay. So, this again shows you a picture where on the x-axis we have time, and this sort of line is where anything above this is large language model. So, we can see that initially we had a few of these tiny dots, and now we have this huge. So, there is a sudden boom of models in the last 1 year, in fact, 1.5 years. Anyways, so that is enough. So, how do you use these models? So, you have a model, a large language model, and then the input to the model, in the sense of well, input in a typical deep learning model discussion is what you feed to the model, and then the model evaluates through a function and gives you an output. Okay. So, if the model has been trained, so you have the optimum values of weights for the model, all the parameters, then you can do inferencing. So, inferencing is you give a new input and it predicts an output out of it. So, in the case of large language models, you give a prompt, which is basically some sentence which has some words, and these words are called tokens. Okay. So, there is a context window as to how long your input can be, or how many tokens can you supply to the model as an input when doing inferencing. So, this is inferencing, the model has already been built, the parameters have been optimized, now you want to predict an output as a function of the input that you give to it. So, if you go beyond the context window, because it has been trained for a certain size of the input. So, if you go beyond that, it can only take the first few words and then work on that. So, this context window can be a few thousand words. Nowadays, Gemini is coming with huge context window, as they say. I have not used it. Well, it is so large that you can actually put books into it, and then based on a book that you feed into Gemini, it can basically give you an answer right away going to that book as an input, as a prompt, not just getting trained on that book, it is actually a prompt. Okay, then it gives you a completion as an output. So, the prompt, and then you have a completion. So, the completion is the output. Okay, so, you say a prompt completion pair, input output. So, transformers, as I said that this is where everything changed in 2017. So, there was a paper in a conference called "Attention is all you need," and that is when suddenly there was a boom in, well, I am not an expert in this field, there are experts in the institute who teach deep learning, so they can explain these in a much more detailed and technical way. So, this was the paper that changed everything. So, on the right hand side is the architecture of a transformer. So, what happens in, well, so you can see that there is, well, this is called an encoder, this is called a decoder. There is no need to go into that, but we need to understand a few things. If you remember that in deep learning, we said that when the example that we took the other day, that was of the input was picture, right, a picture which had a 0 or a 1 written. So, the input was a picture, but we had to convert that picture into numbers. So, we converted a 20 by 20 pixel image into an input of 400, or a vector of size 400, which had these 400 numbers. Okay. So, the input has to be some numbers, because that's how these models work. So what the first job is to convert the text that you give to a token, which is basically some number. So there's a mapping between the words and some numbers. So these are called token IDs that you give as an input. So when you write text, this tokenizer that will convert this sequence of words into a sequence of tokens or numbers, which are actually then converted to vectors. So each token is actually like a vector. Okay. So if you have these four, let's say you have four words with 4 tokens, so these will become vectors for the understanding of this. And if you have lots of tokens, then you have vectors, lots of vectors, and each vector also has some dimension. So let's say the dimension is 512. So each vector is 512 size long, and to understand some sort of an analogy, so if you look in 3 dimensions, let's say the vectors were 3 dimensional. So in that case, what happens is a word which is here and a word which is here, they are closely related in the context of the input that you have. Okay, so if the angle between the words is small, again this is talking, but the concept is general in an n dimensional space. So if the angle between them is small, then the words are close to each other in the form of in the terms of context. So then what happens is once the vectors, the input is fed through the embedding, these are called embedding vectors. So then it goes to a deep learning layer or a deep learning network, in fact, not a layer. There are lots of layers of neurons. It's called a self attention layer. So there are 2 layers, self attention layer and feed forward, two networks, sorry, self attention network and a feed forward network. But you can think of this as, there's one neural network and then there's another one. So this is self attention network actually has most of the parameters or most of the neurons in it. So most of the weights are here that you have to train. Then there is a feed forward network, which is another network. And then what comes out of this feed forward network is, if you remember, we talked about in the last lecture, in the logistic regression, we said that there is a function called a sigmoid function, 1 upon 1 plus e to the power of minus z, where z is w dot x plus b. Okay. So here also what comes out as an output of this feed forward network is these logits, which are z's. Okay. And then you can convert or take a take a sigmoid of that to get some sort of a probability. So once you have this, then you can there's something called a softmax layer, and the softmax layer is like a sigmoid function. So sigmoid function was for a 0 or a 1. Softmax is so 0 or a 1. We talked about a categorization which is binary. So it can be, tumor can be malignant or benign, but there are situations where your output can have multiple categories. Okay. So in that case we use a function called softmax function. So if you talk about 2 categories, it becomes a sigmoid function. But the whole idea is that whatever ultimately, remember, there's some output has to be some sort of words, some answer. So what happens is the ultimate output is once these networks are ready, the weights are trained, then what happens is that we start, let's say the decoder, we feed to the decoder some word, and then that's like, let's start the process. So when the word goes in, and using the context that was fed, so when the word goes in, sorry, from here, and the context was already fed from here, what happens is it predicts what the next word has to be. So it sort of has a list of all the words in the dictionary, let's say, and it predicts the probability of the word that should come next for each or for all the words in the dictionary. Okay. That's the easiest way to do things, right? So if I give you the whole dictionary, then definitely your answer will be have words which will be in the dictionary. So for every step, if I give you one word as to start, then you predict the next word by giving me a probability distribution where each word has some probability that should come next, and then I can decide how I should choose the next word. So, there are different ways to choose the next word that we will discuss in a bit. Okay. So, again this is a very cursory discussion on these because that is not the real aim, but since we will be using some words and terms, you should understand that. So, now we will talk about inferencing and prompting because that is something you readily use if you would want to use a model. So, again as we discussed, there is a prompt, right, and then there is right. So, there is a prompt, there is a context window where you fill in the prompt, there is a model, and then there is a completion that happens. So, typically the free chat GPT nowadays has 8,000 tokens in a context window, and Gemini 1.5 Pro has up to 1 million tokens possible, but not everybody has the access, but they say that some of the people have been given that access. Right. So, what do we do? How do we write the prompts? That also matters. So, this is called prompt engineering. Many of you may have tried that out with ChatGPT, how best to write a prompt. So, there are different ways to prompt a large language model. So, one is called a zero shot inference, which is basically you give a question. So, the question is classify this review, I loved this movie, sentiment. So, now it has to give you an answer, is the review a positive review, a neutral review, or a negative review. Okay. So, this is a zero shot inference, and you just give a question, the model figures out what to answer. So, if you have a large model like ChatGPT which has lots and lots of parameters, then it can actually do a good job. With ChatGPT, if you give this kind of a prompt, it will definitely give you some useful output because it has lots of parameters that has been trained on lots of data. But if you use a very small model which has only a few parameters, well, not that many parameters, let us say it only has a few million parameters, then if you give a prompt like this, it may give you some gibberish out of it because it does not know how to deal with these prompts. Okay. So, for that we use something called in context learning, where we give a few shots rather than a zero shot, we give a few shots. So, this is the prompt will be like this: classify this review, I love this DVD, sentiment positive. So, I tell the LLM that this is the question and this is the answer, some examples, and then now for this particular case you tell me what the sentiment is. So, this is called a few this is basically two shots. Zero shot is I just give the question, one shot is I give one example and one question, few shots is you give a few examples and then the question. So, with a few shots, with a small LLM, it can actually do a good job. Okay. So, this is simply prompt engineering, you figure out what the best prompt is, the model is fixed, the weights are fixed, you are not changing, you are not touching that. Okay. So, you can start with a zero shot, if it does not work, then try a one shot with the same small model and go to a few shots, but that again depends on how big your context window is. If you give too many shots, well, the context window is not big enough, then you cannot feed all the information as an input. There are some configuration parameters that you can change. So, for example, there is a parameter called max new tokens. So, whenever you get an output from the transformer architecture, there is a parameter that you can give max new tokens. So, what happens is that is the longest number of there is the largest number of tokens you can have in an output. But again, if the model sort of feels that there is an end, there is a full stop, now there is enough information, so the answer can be smaller than the max new tokens definitely, but it cannot be larger than these tokens. So, this is a parameter that you can change. Then there is a parameter for sampling, greedy versus random sampling. So, as I told you that the final output is basically a distribution. So, if let us say the first word is the, and the next word is how does it figure out what the next word is? So, if it gets a probability distribution of all the words in the dictionary versus the probability, it chooses the word which has the largest probability. So, that is called a greedy sampling. The other is random sampling, where rather than, because see if it uses greedy sampling, it can actually sometimes give you a result which is not what you want, or there is no creativity as such in the result. So, the other way is called random sampling, which is more useful in general. So, where it takes the first few words which have the largest probability in the dictionary for the next word that should be predicted, and then it randomly weights the words based on the probability that they have. So from this you can see that there is a 20% probability then cake should be the next word, but there is a 2% probability that banana should be the next word. So now I choose a number between 1 and 100, and I say that if the number is less than 2, then you choose banana. If it is between, let's say 3 and 10, then you choose donut, and so on. So what it means is that now with the distribution that I have, I can still randomly choose, and there will be 2% cases where banana will get chosen. Okay, so even words with lower probability can be chosen at times. So this is called a random sampling. And then there's the parameter called top p and top k, which is like you don't want to have a distribution of all the words. You see the first few words, the top rated words that you choose from them. There's a configuration parameter called temperature. So it's low temperature is cold, there's no creativity, higher temperature is high creativity. So basically what it means is the distribution is for low temperatures is peaked, and for higher temperatures it's you basically sort of broaden the distribution. So the chances of choosing these words actually is much higher in the higher temperatures. So if temperature is very high, you sometimes get some kind of an answer which a drunkard would give. It's quite random. Okay. So now this was some basic understanding of transformer architecture and the different parameters that you can tweak. So this is how a life cycle of an AI project or a generative AI project looks like. You define the use case, you choose an existing model, you decide whether you want to choose an existing model or you want to pre-train or train from scratch your own model. And then once you have chosen, let's say, an existing model, then you check, you give it a few prompts and see if the output that you are getting is what you expect. You evaluate basically the output. If you are not happy with it, then you fine tune it, that we will discuss today. So you basically improve the model, you evaluate or you further optimize the parameter values. So the parameter values will get changed in fine tuning. And there are other things as well where you align with the human feedback and so on, but we will not go into those details today. And then you deploy it. So let's have a look at how many of you here have used Hugging Face, the website. Have ever visited this website called Hugging Face? Heard of it? Okay. So let's quickly because in most cases we will be picking a model which already exists, because these models, the large models, have been trained on thousands of GPU cards for thousands of hours. So we don't have that kind of a resource, at least here at the institute, to train large models from scratch. So but there are many open source models available. So what typically we do is we either use them as they are or improve them through fine tuning. So first is we have to figure out which models or what model should we choose. So for that we go on, there is this repository called or this ecosystem called Hugging Face, which has actually become sort of a standard nowadays for LLMs. Right. So this is the Hugging Face website. So you can see that there is a model tab here. So if I click it, then it gives me the type of models and so on. So let's say I am looking for models which are doing natural language processing. So let's say text classification, and then I look at the trending model. So let's pick this one. Okay. So there is a model card firstly. So this is the model card. Right. So this sort of model card will give you what are typical inputs and what is the typical output out of it. The models can be quite general or quite specific depending on the kind of model that you're dealing with. So you can look at the number of parameters. It's 67 million parameters. That's nothing. Okay. So this is a small model. This is 32-bit. So the numbers that it is using, the parameters it has are represented as 32 bits floating point numbers, so that means 4 byte. So they are not double, they are single precision numbers which are used for parameter calculation. So then there is some API available as well if you just want to try it out. So this is, let's say we write good and we compute it. So this is happening on their server. So it says that it's a positive review. So this is basically a classification that tells you whether the text is what is the sentiment in the text. If you write this is bad, so these are very clearly, this is clearly negative. So this is how you can play around with, and you can read more about the model if you want to. It also gives you some sort of a code that you can just copy and paste and play around with. Okay, then you can go to files. This is the actual files that will get downloaded if you want to use the model on your local machine, and it has some community discussion where people are posting things. Okay, and there are lots of these models like this. So then you have to decide which one to go. So this is a trending one which has 6 million downloads last month. Seems to be a good one if I want to try things out on a small model to start with. The model that we'll discuss is called a T5. It's called T5. So let's search for this. T5 base. So FLAN T5. So this is by Google. I mean, you can also create models and share on this hub. It's called Hugging Face Hub. So this is it gives you some sort of an input and output, and then you can play around with these. So some models have an API available on the internet, some don't, depending on what they have enabled. And then again, as I said, that there's plenty of things you can read about the model. This is called a model card that you want to start with before you actually start using it. And then again, in this, it's possible to it's connected to some tools available on the clouds. If you want to train it, you want to deploy it, and so on. So you can use, if you click it here, it will automatically open an instance of Amazon SageMaker, and you can it will open some sort of a notebook that you can work with. Okay, so let's do inferencing, because that's what we want to start with. So for that, I'll be using Windows. So in that, I have an environment created in Anaconda. So the notebook from last time has been shared on the codes folder on Google Drive. So that link is there in the Moodle repository, so you can have a look at the code. So this will also be shared on that if you want to play around with it. Okay, so first it says in this lab you will you don't have to do it. I'll just demonstrate to you. You can try it out later because you won't have these things installed on your system anyways. So we'll try out inferencing, 0 shot, 1 shot, and so on. So first you need to install a few things. I already have done that, but there are some instructions here if you want to do it. And the Python version that I have is 3.10. It can be quite selective in terms of the version these libraries. So first I do import some modules. So in terms of modules, I have the datasets modules, which is basically used to load a dataset. Because see, when you are dealing with a model, even though we are not training it, but we want to evaluate it. So we already have a data set where people have given put in some input in terms of, let's say, some text, and then they have also provided some sort of an output that should be predicted by an ideal model, which we call a human baseline. So if you ask a smart human about that question, that's how they would answer. So this is like a supervised learning. So you have an input and you have an output. So that's the data set that we're downloading. So what we'll do is we'll take these prompts from the data set rather than writing them here, and we'll let the model predict an answer and compare that with the target which is called the human baseline, also available in the data set. Okay. So we imported, and transformers is this a module available in Hugging Face. So I have already downloaded that. So it has some classes called sequence to sequence, tokenizer. So tokenizer is to convert that words to those tokens, and then generation configuration is, as I told you, you can change the temperature, you can change the distribution and so on. So you can configure those things here in the generation config class, and this is simply to load a model which is sequence to sequence. So you give it some sequence of words, it returns a sequence of words. Okay, so first so the way we supply a data set is we basically actually, let's say we go to data sets. In the data sets, I'm looking for a data set called dialog sum. So this is a famous data set. So this is the person KN Karthik who has uploaded this data set. So this is the data set that's available. And then again there's a data set card which tells you some basically it has it has all the data. So it has training, validation and test. So typically what happens is whatever data you have, you split it into 3 parts. One's called a training data, which has the most of the data in it, and then you have validation data. We don't need to discuss that now, and then there is testing. So training is the data that you train it on, and once the model is trained, you give it some new data to test how good the model is. This is to prevent overfitting issues. Validation is typically to train some, to decide or to choose on some hyperparameter values and so on. Okay, so this is the dataset name, and then there's a function called load dataset available in the dataset module, which when you supply this, it loads the dataset from the internet. So it is now connected to the internet. It is basically downloading this dataset. I could have actually not called this cell at all. I would have downloaded that from the Hugging Face website and stored that on my computer in the same folder. So now if I want to have a look at it, so this is a dictionary, this data set. Okay. So you can see it has a train, validation and test 3 parts, and then each one has a few features and number of rows is 12,460 in the train key, and then for validation and test you have 500 and 1500 rows or tokens respectively. Let's call it rows. And then each row has these columns, an ID, a dialogue, a summary and a topic. So this is called dialogue sum. This is basically dialogue summary. So what it has is, it has a dialogue, a conversation between 2 people, there's a whole dialogue, and then it has a summary. So that's what this data set is, dialogues and summary of what's happening in that. Okay, so that's a summarization that we talked about in the beginning. It also has something called topic, which is what is the topic. If you want to look at, let's say, let's look at in the test, let's look at, because test has a total of 1500 rows. In the first row, let's look at what the topic is. If I do that, then the topic of this conversation is communication method, and if I look at the summary, then it tells me this is the summary. If I look at the dialogue, then so this is the whole dialogue. Okay, then I can change this index and I can see different dialogues, and each one also has an ID, some ID associated with that row. So if you want a different data set, you can choose. So this data set was developed by IIT Bombay, which translates English to Hindi. So I can go to Hugging Face website, just search it here. So this is so it again has a split between. So this is a large. It has a total of 1.66 million rows in the training split, and then test has 2,500 rows. So I can just click here, and it tells me what data it has. Okay, so it has a first a column where it has the English text, and then it also has then the Hindi text. Okay, so now you can see that it actually downloaded this data set on my machine. And then now that I have loaded it, I can see what the split is. I can in fact have a look at one of these and see what the data is. Okay. So, I can do whatever I want with the data, but for now I just wanted to show you how to get data from Hugging Face onto your notebook. So, let us go back to our dialog summary data set that we have just downloaded. So, what we will do is we look at two particular dialogues just to understand things. So, let us see an example. So, this is an ID number this for a topic on transportation. It has this dialogue and it has the summary, which we will call it a baseline human summary. So, that is what the summary of a smart human is who understands this dialogue, and then we will compare, we will let the model, we let some model create its own summary, and then we will compare that with the human baseline summary. So, this is some discussion between two people where person 1 is in a hurry to catch a train and Tom tells person 1 that there is plenty of time, do not worry. And there is another one where somebody is trying to upgrade their system and so on. That is not important right now. So, the model that we are choosing, as I told you, this is a T5 based model. This is called FLAN T5 base. So, this was developed by Google, and then so first we have to supply the model name, and then we can use this auto model for sequence to sequence to load this model, and we give the model name here. So, now what will happen is it will download this model, which is how big was it? Let us have a look. So, this had a total of 240, so it had a total of let us say 250 million parameters, and then each parameter is represented as 4 bytes. So, if you multiply 4 by 250, you get 1 billion bytes, that is 10 to the power of 9. So, that is 1 gigabyte. So, that is the size of this model, it is around 1 gigabyte. I can actually check because I know what is the path where it downloads. So, in your home there is a .cache folder which has Hugging Face folder, and then it will have hub where it has all the models. So, the one that I am using is FLAN T5 base. So, I had already run this earlier, so it is in the cache, it will not download it again, but if I delete this folder it will download it again. So, I can actually have a look at this folder size, which may have a few other files as well, but more or less it will give me some sort of an estimate. So, this is 947 megabytes, so around 1 gigabyte, okay. That is what we estimated.